In this video, we're going to focus on balancing chemical equations. So let's get right into it. Let's start with a combustion reaction. So here we have propane C3H8 plus oxygen gas, and that's going to produce carbon dioxide and water. Now, whenever you want to balance a chemical reaction, your goal is to make sure that the atoms are equal on both sides of the reaction. For this particular combustion reaction, we want to balance the carbon atoms first, then the hydrogens, and then the oxygens. We'll save that for last. So notice that we have 3 carbon atoms on the left side. That means we need 3 carbon atoms on the right side. And here we only have 1 carbon atom in CO2. So what we need to do is put a 3 in front of carbon dioxide. So now we have 3 carbon atoms on both sides. So let's move on to the hydrogen atoms. Notice that we have 8 hydrogen atoms on the left side. And the only molecule that has hydrogen is water. What number do we need to put in front of H2O? 8 divided by 2 is what number? 8 divided by 2 is 4. So you need to put a 4 in front of H2O. So you have 8 hydrogen atoms on both sides. Now let's move on to the oxygen atoms. What is the total number of oxygen atoms on the right side? Notice that we have 6 oxygen atoms in the 3 CO2 molecules. If you multiply 3 by 2, you're going to get 6. And we have 4 oxygen atoms in the 4 water molecules. If you don't see a subscript, it's a 1. 4 times 1 is 4. So we have a total of 10 oxygen atoms on the right side. So what number do we need to put in front of O2 so that we have 10 oxygen atoms on both sides? 10 divided by 2 is 5. So we need to put a 5 in front of O2. So everything is balanced. We have 3 carbon atoms on both sides, 8 hydrogen atoms, and a total of 10 oxygen atoms on both sides. And that's really what you need to do to balance an equation. Just make sure the number of atoms on both sides are equal. So now let's try another example. Butane C4H10 plus O2 produces CO2 and water. Go ahead and balance this reaction. So just like the last example, let's balance the carbon atoms first. We have 4 carbon atoms on the left side. So 4 divided by 1 is 4. We need to put a 4 in front of CO2 to make it work. Now let's move on to the hydrogen atoms. Notice that we have 10 hydrogen atoms on the left side. 10 divided by 2 is 5. So we need to put a 5 in front of H2O so that we can have a total of 10 hydrogen atoms on both sides. Now, how many oxygen atoms do we have on the right side? So in 4 CO2 molecules, we have a total of 8 oxygen atoms. 4 times 2 is 8. In the 5 H2O molecules, we have a total of 5 times 1 oxygen atoms, so just 5. So we have a total of 13. And if we try to balance the equation, we're going to have a fraction. 13 divided by 2 is 13 over 2. Right now, this reaction is balanced, but we need whole numbers. We don't want fractions. So all we need to do at this point is we simply need to multiply the equation by 2. And then it's going to be balanced. So it's going to be 2 C4H10 plus 13 O2. We're going to have 8 CO2 molecules and 10 water molecules. Now let's make sure our answers are correct. Notice that we have 8 carbon atoms on both sides. 2 times 4 is 8. And we also have 20 hydrogen atoms. 2 times 10 is 20. And let's check the total number of oxygen atoms. 13 times 2 is 26. So we have 26 oxygen atoms on the left side. 8 times 2 is 16. 10 times 1 is 10. So 16 plus 10, that's 16 oxygen atoms. So this equation is balanced. Let's try this one. Aluminum plus hydrochloric acid produces aluminum chloride and hydrogen gas. So feel free to pause the video and work out this problem. Let's begin by balancing the number of chlorine atoms. We have 3 chlorine atoms on the right side and only 1 on the left side. So our natural inclination is to put a 3 in front of HCl. The only issue with that is we have an odd number of hydrogen atoms on the left side, but an even number of hydrogen atoms on the right side. Whenever you come across this even-odd situation, you can rectify the situation by simply multiplying everything by 2. So instead of putting 3 in front of HCl, let's put a 6. So we have 6 chlorine atoms. That means that we need to put a 2 in front of AlCl3 because 6 divided by 3 is 2. So we have 6 chlorine atoms on both sides. Now we have 6 hydrogen atoms on the left, but only 2 on the right. So what number do we need in front of H2? 6 divided by 2 is 3. So we need to put a 3 in front of H2. So we have 6 hydrogen atoms on both sides. Now we have 2 aluminum atoms on the right side, but only 1 on the left side. So we need to put a 2 in front of Al. So now the reaction is balanced. This is the answer. So here's another example. Gallium plus copper bromide produces gallium bromide and copper metal. Go ahead and balance the reaction. So notice that we have 2 bromine atoms on the left side and 3 on the right side. So we have that even-odd situation. The least common multiple of 2 and 3 is 6. So what you want to do is you want to try to get 6 bromine atoms on both sides. 6 divided by 2 is 3. So let's put a 3 in front of copper bromide. 6 divided by 3 is 2. So we'll put a 2 here. So notice that we have 6 bromine atoms on both sides of the equation. So now at this point, we just got to balance the other atoms. We have 3 copper atoms on the left, so we need to put a 3 in front of Cu. And we have 2 gallium atoms on the right side, so we need to put a 2 in front of Ga. And the reaction is balanced. That's all you got to do for this example. Try this one. I2 plus F2 produces IF7. Go ahead and balance the reaction. So here we have the even-odd situation. We have 2 fluorine atoms on the left, 7 on the right. The least common multiple of 2 and 7 is 14. So that tells us that we want to try to get 14 fluorine atoms on both sides. 14 divided by 7 is 2, and 14 divided by 2 is 7. So notice that the fluorine atoms are balanced. And we already have 2 iodine atoms on the right side, 2 on the left. So this reaction is balanced. You can put a 1 here if you want, but you don't have to. But that's all you got to do for that example. Try this one. SO2, sulfur dioxide plus oxygen gas produces sulfur trioxide. Go ahead and balance the reaction. So we have a total of 4 oxygen atoms on the left side and 3 on the right side. What can we do in this particular example? If we make this a half, notice that the reaction will be balanced. We have 2 oxygen atoms in SO2. A half times 2 is 1, the 2's cancel. 2 plus 1 is 3. So it's balanced, but we don't have any whole numbers. So what we need to do is multiply the equation by 2. So 2 SO2, 2 times a half, we said it's 1, so 1 O2 produces 2 SO3 molecules. Notice that it's balanced at this point. So we have 2 sulfur atoms on both sides. On the right side, we have 6 oxygen atoms. 2 times 3 is 6. On the left side, we have 4 oxygen atoms from the 2 SO2 molecules, plus another 2 oxygen atoms, and so that adds 6. So we can see that we have the same number of oxygen atoms on both sides. So this is the answer. This is the balanced reaction. Consider this reaction. Sodium metal plus elemental sulfur produces sodium sulfide. Let's say if we have sulfur in its S8 form, how would you balance this reaction? What would you do? So we have 8 sulfur atoms on the left, but only 1 on the right. So that tells us that we need to put an 8 on the right side, since 8 times 1 is 8. So we have 8 sulfur atoms on both sides. How many sodium atoms do we have on the left side? 8 times 2 is 16. I meant to say on the right side, not on the left side. So we have 16 sodium atoms on the right side. That tells us that we need to put a 16 in front of Na. And now the reaction is balanced. So the coefficients are 16, 1, and 8. Try this one. Sodium phosphate, Na3PO4, plus magnesium chloride produces sodium chloride and magnesium phosphate. Go ahead and balance this reaction. This is called a double replacement reaction. And for these types of reactions, you don't always want to balance each atom individually. It might be easier to view phosphate PO4 as an entire unit. It's going to make it a lot easier. Notice that we have 1 phosphate unit on the left, but we have 2 phosphate units on the right side. If you see it that way, it's going to be easier to balance it. Let's put a 2 in front of the left side, so we have 2 PO4 units. Now notice that we have 6 sodium atoms on the left side. 2 times 3 is 6. So we have 6 sodium atoms. Therefore, what number do we need to put in front of NaCl? So we got to put a 6 in front of NaCl. So we have 6 sodium atoms on both sides and 2 phosphate units, or PO4 units, on each side. Now notice that we have 3 magnesium atoms on the right side, but we have none on the left side, so we got to put a 3 in front of Mg. So we have 3 magnesium atoms on both sides. Now notice that we have 6 chlorine atoms on the right side and 6 on the left. 3 times 2 is 6. So this reaction is balanced. Here's another double replacement reaction that you could work on. Potassium sulfate, K2SO4, plus aluminum chloride, AlCl3, produces potassium chloride and aluminum sulfate, Al2SO43. Go ahead and balance the reaction. So let's start with the sulfate units. That's the SO4 units. Notice that we have 1 SO4 unit on the right, but 3 on the left. So that tells us that we need to put a 3 in front of K2SO4. So we have 3 sulfate units on each side. Notice that we have 2 aluminum atoms on the right side. So we need to put a 2 in front of AlCl3. So we got 2 aluminum atoms on both sides. Once we do that, notice that we have 6 chlorine atoms on the left side. So we got to put a 6 in front of KCl. Once we do that, we have 6 potassium atoms, and 3 times 2 is 6, so everything is balanced at this point. So this is the answer. The coefficients are 3, 2, 6, and 1. Let's try another example. Ammonia plus oxygen gas produces nitrogen monoxide and water. So what can we do to balance this reaction? So it appears as if the nitrogen atoms are balanced. We have 1 nitrogen atom on both sides. The hydrogen atoms are not balanced. We should save oxygen for last because we can always modify it since we have O2 by itself as a pure element. So let's not worry about oxygen for now. Let's start by balancing the hydrogen atoms. So we have an odd number of hydrogen atoms on the left and an even number on the right side. So let's double the number of hydrogen atoms. So we have 6 on the left side, which means we need 3 in front of water. So we now have 6 hydrogen atoms on both sides. So now at this point, we have 2 nitrogen atoms on the left, only 1 on the right. So we need to put a 2 in front of NO. So we have 2 nitrogen atoms on each side. So now let's look at oxygen. We have 2 oxygen atoms in the 2 NO molecules and 3 from 3H2O. So we have a total of 5, which is odd. And here, if we balance it now, it's going to be 5 divided by this number 2. So as a fraction, it's 5 over 2. Even though the reaction is balanced, we don't want to leave it like this. We need to multiply everything by 2. So it's going to be 4 NH3, 5 over 2 times 2. The 2's will cancel, and so it's going to be 5O2, and 4 NO plus 6 H2O molecules. So now the reaction is balanced. So if we check our work, we can see that we have 4 nitrogen atoms on both sides. Here we have 4 times 3, which is 12. 6 times 2 is 12. So we have 12 hydrogen atoms on each side. Here this is 4 times 1, that's 4. 6 times 1 is 6. So we have a total of 10 oxygen atoms on the right side. 5 and 2 is also 10. So everything is balanced. Try another combustion reaction. Ethanol plus oxygen gas produces carbon dioxide and water. CO2 and water are always the products for a combustion reaction. So let's begin. Let's start by balancing the number of carbon atoms. Notice that we have 2 carbon atoms on the left, so we need to put a 2 in front of CO2. Now, how many hydrogen atoms do we have on the left side? We have 5 plus 1, so we have a total of 6. So what number do we need to put in front of H2O? 6 divided by 2 is 3. So we need 3 water molecules, so that we have 6 hydrogen atoms on both sides. So now, let's move on to the oxygen atoms. In the 2 CO2 molecules, 2 times 2 is 4. So we have 4 oxygen atoms there. 3 times 1 is 3, so we have 3 oxygens in the 3 water molecules. Notice that we have an oxygen in ethanol. So we need a total of 7 oxygen atoms on both sides. So what number goes here? Let's call it x. So 1 plus x equals 4 plus 3. 4 plus 3 is 7. 1 plus what number is 7? That missing number is 6. 7 minus 1 is 6. So we need 6 oxygen atoms from O2. 6 divided by 2 is 3. So we got to put a 3 in front of O2. So now everything is balanced. We have 2 carbon atoms on both sides, 6 hydrogen atoms, and a total of 7. 3 times 2 is 6, plus 1, that gives us 7. 2 and 2 is 4, 3 and 1 is 3, 4 and 3 is 7. So everything is equal, and the reaction is now balanced. So that is it for this video. Thanks for watching, and have a great day.